This is example 1 of section 10.3. So this tells you that there is a point. The point is -4, 3, and it lies on this circle. Now it doesn't say that it's a unit circle. We don't know that the radius of the circle is 1. So when we have learned that sine is y and cosine is x, that only works on the unit circle. So this is just a circle, not the unit circle. So it says evaluate the 6 trig functions of theta. Okay, well, you are taking this triangle right here, and if the x value is -4, that's this distance, and the y value is 3, that's this distance. So I'm going to draw it just a little larger over here. Same triangle, I'm just drawing it over here. So this side is -4, this side is 3. And the reason this side is negative is because of the direction where it is. I know side lengths are supposed to be positive, but this includes the direction on a graph. So then to find this missing side, we use the Pythagorean theorem, because when we know two sides of a triangle, we can use the Pythagorean theorem to find the missing side. So A and B are the legs, and then C is the hypotenuse. So we're missing the hypotenuse, so C is our variable. So we get, let's see here, 9 plus 16 equals C squared. And so that's 25. And the square root of 25 is 5. So this side is 5. All right, so to find the sine of the angle, you do the opposite over the hypotenuse. So the opposite side is going to be 3 over the hypotenuse is 5. All right, cosine is adjacent over hypotenuse. Adjacent is -4 over the hypotenuse, which is 5. Tangent is the opposite over adjacent, so 3 over -4, or -3/4. All right, cosecant is the reciprocal of sine, so sine was 3 over 5, cosecant is 5 over 3. Cosine, the reciprocal of cosine is secant, so you do the reciprocal and you have, instead of -4/5, you have -5/4. And then cotangent is the reciprocal of tangent, so instead of -3/4, you have -4/3. Okay, so if you'd like to see that again with another problem, we can go ahead and do this one. I don't think we'll do the additional one. This one is a great example because not all of the numbers are whole numbers, so it's definitely worth taking a look at. So it wants us to do the 6 trig functions of this point, 3, -3. And if we make this a triangle, always make one side of the triangle be on the x-axis. So for just the ability to see it, I'm going to draw it just a little bit bigger right here. Okay, so the x value is 3 and the y value is -3. So this is 3, -3. All right, so to find the radius or the hypotenuse, we're going to do the Pythagorean theorem. So we're going to do 3 squared plus -3 squared equals the C squared. Okay, so we get, let's see here, 18. And then we square root it. And when we square root 18, we want to break it down. Remember how we do that is we have 2 and 9 and 3 and 3. And so remember that makes 3 square root 2. So our C is 3 square root 2. Okay, this is where our angle is if you look at where it's drawn on the picture. So if I want to find the 6 trig functions, I'm going to do sine of theta equals opposite is -3 over hypotenuse is 3 square root 2. Now the hardest part about this is that you have to go ahead and simplify things. So the first thing I'm going to do is these 3's cancel out, and so you just have -1 over square root 2. And then to get rid of the square root 2 on the bottom, you've got to multiply by square root 2 over square root 2. So that gets negative square root 2 over square root of 2 times square root of 2 is 2. That's the answer to sine. Okay, so now to do cosine. Cosine is adjacent over hypotenuse. So the adjacent side is 3. The 3's can cancel out, and you just have 1 over square root of 2, but that square root cannot be in the denominator, so we multiply by square root of 2 over square root of 2. So we have square root of 2 on top and 2 on bottom. Okay, and so tangent is opposite over adjacent. So opposite is -3, adjacent is 3. -3 over 3 is -1. All right, I'm going to use this space right here for this one since we're not going to do it. So I'm going to do my cosecant here. My cosecant is 1 over sine, or since sine is opposite over hypotenuse, it's hypotenuse over opposite. So the hypotenuse is 3 square root of 2. The opposite is -3. And then that simplifies, the 3's cancel out. So you're left with just negative square root 2. All right, secant is the reciprocal of cosine. So if cosine's adjacent over hypotenuse, this is hypotenuse over adjacent. So the hypotenuse is 3 square root of 2 over the adjacent is 3. The 3's cancel out and square root of 2 is just your answer. And then cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, this is adjacent over opposite. Adjacent is 3, opposite's -3, we get -1. So that's one where you have to deal with the radical on the denominator. So I thought it would be a good example to watch.